Today we discuss about self-stopping counter. Today we discuss about self-stopping counter. Okay. So first of all, what is the meaning of self-stopping counter? This is self-stopping. Self-stopping means, okay, first of all, the difference between the mod counter, and the self-stopping counter is that for a mod counter, say for mod n counter, the counting states are 0, 1, 2, and after n minus 1 it goes back to 0. Say for example for mod 7 counter, that means the counting states are 0, then 1, then 2, then 3, then 4, then 5, then 6, and back again to 0. So this is the primary characteristics of any mod counter and the sequence of any mod counter. That means if we define mod n, then it count up to n minus 1 and then again come back to initial state 0, and again repeated 1, 2, 3, 4, n minus 1 and again 0. But in a self-stopping counter there have some difference. So what is the difference? First of all, this self-stopping counter is also known as n only n counter. Okay, this is very important. N only n counter. That means this n only n counting means, for example, if we take for example 6 only 6 counter, for example, just for an example, if we take an example 6 only 6 counter, then the counter counting state like that: 0, then 1, then 2, then 4, then 5, and then 6, and stop here. No other states are possible. That means it initially counts from 0, then 1, then 2, then 4, then 5, then 6, and stop here. It not come back to again 0 initial condition. It is not possible in the self-stopping counter. So that's why it is known as self-stopping. And what is the value? The value is mentioned here. If this is known as 5 only 5 counter, if we mention 5 only 5, then the counting state 0, then 1, then 2, then 4, then 5, and just stop here. Just stop here. Okay. So this is the primary difference between any mod counter and self-stopping counter. Okay. Just missing here. Sorry. Just missing here. Here also mentioned these are 3. Just missing this step. So this is the step is 0, 1, 2, 3, 4, 5. Okay. So this is the primary difference between mod n counter and n only n counter. So here, for example, for 6 only 6 counter, the counting states are 0, 1, 2, 3, 4, 5, and 6, and then stop. And for 5 only 5 counter, for example, the counting states are 0, 1, 2, 3, 4, 5, and just stop here. But for mod counter, if we again for mod 5 counter, then counting states are 0, 1, 2, 3, 4, and then come back again 0, because for mod 5 the 5 minus 1, that means the last state is 4, and again its initial state is 0. So this is the primary difference between the mod counter and the self-stopping counter. Okay, now we discuss about the basic hardware functionalities to design the self-stopping counter, how we design the self-stopping counter using JK flip-flop and other necessary logic blocks. So first of all, there are basically two types of method. There are two methods by which we design the self-stopping counter. Number one method is known as least significant bit disable method. This is very important. LSB disable method, least significant bit disable method. And number two is clock disable method. Clock disable method. Okay, anyone we can use for design the self-stopping counter. Anyone, either LSB disable method or either clock disable method. So first of all, in this LSB disable method, the mechanism is that we make LSB bit from toggle condition to the no change condition, and for clock disable method we disable the clock. So this is the primary difference between the LSB and the clock disable method. And in the next, we design, our objective is design 3 only 3 counter, 3 only 3 self-stopping counter, stopping counter. Okay, not this is 3, this is just assume 4. This is 4, only 4 counter. Okay, so the counting, what is the state diagram? The state diagram is 0 0 0, then 0 0 1, then 0 1 0, then 0 1 1, then 1 0 0, and just stop here. Okay, and just stop here, just stop here. 0, this is 0 state, this is 1 state, this is 2, this is 3, and this is 4. So first of all, using LSB disable method, what is the hardware diagram? The hardware diagram is look like that, and here we mention that here 3 flip-flops are required because number 4 is represented by least number of 3 bits, that is Q2, Q1 and Q0. So here first of all required 3 JK flip-flops. This is J0, K0, this is Q0 and Q0 bar, and the second flip-flop is J1, this is K1, this is Q1 and Q1 bar, and this is J2, K2, and this is Q2, Q2 bar. So just like a binary up counter, we connection every point, that means every JK is connected plus VEC. First of all, this is short circuited and connected to plus VEC, but in the least significant J0 and K0 bit not directly connected to the plus VEC, because here some changes of design. First of all, here we connect one AND gate, sorry, and here we connected plus VEC. Okay, here we connected plus VEC, and this is our main clock, this is our main clock, and we know that this is our main clock. Just a minute. Okay, this is our main clock, and here from here the 3 bits are, we get the 3 bits, that means this is Q2, this is Q1 and Q0, and our stopping state, what is the state where the self-stopping counter is stopping? The state is 1 0 0. That means when Q2 equal to 1, that means this is Q2 equal to 1, then Q1 equal to 0, then equal to 0. Okay, so that means here we connected one NAND gate. Okay, here we connected one NAND gate, and those bit are 1, those bit are in state 1, these bit are directly connected to an NAND gate, and those bit which is logic 0, this is inverted via using NOT gate and then connected to the NAND gate. So this is same for this bit. Okay, so this is Q2, Q1, Q0, and the output of this NAND gate is connected with this second input of the AND gate. Now what is the logic? So what is the hardware function? The hardware function is, first this is state 0 0 0. When 0 0 0, the output state of the NAND gate equal to 1. So if equal to 1, then plus VEC is connected here, the AND gate pass the plus VEC, and J0 K0 equal to 1. So when both J0 and K0 equal to 1, that means this is the toggle state, and when 0 0 1, this is also toggle, when 0 1 0, 0 1 1, and when 1 0 0 is coming here, then this output equal to logic low, that means here 0 coming, this 0 is apply in this input. So the AND gate, what is the principle of AND gate? The AND gate principle is that if any input equal to 0, then output will be get equal to 0, and we already know that from the JK characteristics table or transition table, that if J and K equal to 0, that means the output is no change. So now from here, always the all output are in the initial static state, that means the state is 1 0 0. So no other state further is updated, it only stops in the final state 1 0 0. So this is the mechanism how LSB disabling. So here we look that the LSB, the changes of the state from LSB from toggle condition to the no change condition, so that's why it is known as LSB disable method. Okay, so this is very important. Okay, now next we talk about the clock disable method. So clock disable method is just follow the LSB disable method. It's same principle like an LSB disable method, but the only difference is that instead of LSB bit of this JK flip-flop, we can disable this clock. So how is it possible? So the basic hardware is the same, so it is very easy. The basic hardware is basically same. just delete here, delete this NAND gate here, and this clock delete here. Okay, now, so what is the difference? The difference is that instead of this LSB bit, so in clock disable method, the LSB is directly connected to plus VC. Okay, because in the clock disable, the name signifies that we disable the clock only. So how is it possible? So here we connected one AND gate, and then here we connected the main clock, and these output connected here, and this output of AND gate is connected to this AND gate. So now again, when 100 state is coming, then output is logic 0, because this is only 4 counter. If output is 0, then 0 apply here. So the clock is, we don't get any clock at this output. So this flip-flop in this stable state, that means no change state. So the output is remains fixed, that means the output is fixed or keep remain in the fixed state, that is the state is 100. So this is the mechanism of clock disable method. One thing should be remembered, that the LSB disable method and the clock disable method are the same, because in the LSB disable method the principle is just look like the same, but because in LSB disable method we just disable the LSB bit, and clock disable method we just disable the clock. Otherwise the other hardware are the same. Okay, so this is the basic difference between the LSB disable and clock disable method, and by using these two methods we can design 4 only 4 counter and various counter like 12 only 12, 10 only 10, depending on the number of bits. For 10 only 10 there are 4 bits are required, for 13 only 13 there are 4 bits are required. Okay.